Well, good morning.
Good morning. Welcome, guys, to our new episode of ALPHA TEC-Talks. I'm Noel, and with me in studio today, Michael van Rensburg. Mike, thanks for joining us today.
Yeah, good. Thank you for having me again.
Nice. Yeah, it's awesome to have you on the show, Mike. Thank you.
It's becoming a habit.
Oh, yes, it is. It absolutely is. Guys, today we have an awesome show for you today. Today we will be... let me try that again, guys. I'm so sorry. Today we will be discussing Cambridge sound masking. This is one of my favorite topics to discuss because Cambridge has been on the forefront of sound masking technology pretty much forever. And they are very, very good at it. We will also be looking at a few applications of where sound masking is used. So to kick us off today, Mike, can you please tell us what is sound masking, where we would use it, and why?
Yeah, so it's quite simple. Sound masking is exactly what it says. It is designed to hide sound. Right?
Okay, all right.
And I'll call up a presentation here that we can look at a few things on, and we'll look at some of the applications and so on. But what is sound masking? Quite simple. It is a process of adding a low-level background sound that will hide other prominent sounds or speech in an environment. Right?
Okay.
And we'll talk a little bit about more of the details of that as we go through.
Excellent.
It is believed that one of the earliest examples of sound masking is from the Romans using water fountains to make sound of chariots and cobblestones in streets.
I didn't know that.
Right? That's quite an interesting sort of historical piece of information. Right?
That is really clever.
The concept of that, and again, we're just talking about physics. Right? You're just creating, and again, we'll look at the details, but you're just creating a certain level of noise that hides certain sounds based on distance from a sound, or proximity from a sound, or how that sound is affected in an environment. Right? So we'll go through some of the details. But as a really base example,
Yes.
if you see the image that we have on screen there, the person in the background there is asking the person in the foreground, so the lady with the pink asking the lady in the blue, do you want coffee?
Yeah.
Now, if there's no sound masking, or if there's no masking or hiding of her voice speaking to the lady in the front, then she can hear her clearly.
Yes.
But if you look at the example on the right-hand side, so you look at the little basin in front of her. The one side, she's not pouring water into the basin. The other one, she is.
Yes.
Now, that effect of the water pouring into the basin is making her go, what? Because she didn't clearly hear the question from the lady in the back.
There was sound that she was focusing on and didn't hear the lady behind the back because
Yeah, 100%.
of that noise. Oh, okay.
So there was enough of a other noise hiding clear understand and clear intelligibility of the question from speech from the lady in the back of the pink.
Oh, right. That's a
Character in
very
the back.
clever picture to use, hey?
Yeah.
Because, I mean, like in the first picture, you can clearly read what the lady is saying, which means she can be heard very clearly. But then again, when there's other noise added to the scenario, they've kind of blurred it out, making you hard to see. So it helps you to understand that the lady who's washing the dishes cannot understand what that other lady is asking.
Correct.
That's very clever. Very, very clever.
Now, in terms of some of the applications where you would use that, I mean, a typical application would be in a noisy environment like an open office, right? Where you want to be able to have a little bit more concentration, or we'll talk about things in details in terms of privacy and so on. But you want to be able to focus, you want to be clear from distractions as such. So open plan office environments, call centers, are the typical places where you want to introduce sound masking as a concept.
That would make sense.
Some of the other applications, believe it or not, could be places like healthcare. Right? You want to have quieter patient rooms, perhaps privacy in government, right? Where you want to introduce privacy in that sense for secure facilities. You don't want people to understand a specific conversation maybe, or be able to overhear conversations. I will talk about that concept a little bit more. law offices, again, somewhere where privacy might be a requirement. Education, to actually be able to concentrate a little bit better. Retail, showrooms, public spaces. You might even want to introduce it there to have a easier feel environment, right? In terms of person's emotions, because they're not getting distracted by all sorts of noises. Venues and event centers, houses of worship, counseling offices, hospitality areas, guest rooms, spas, places where people actually go to relax. You want to take noise out of the equation, distracting noise out of the equation. And then finance, retail, banks, call centers, as we mentioned earlier. That's typical environments where that gets introduced. And we've done a couple of banks with sound masking in the past.
This is quite interesting, Mike. I mean, I thought that you would only use this in like a few, maybe like you mentioned, the corporate spaces and busy call centers. I didn't think you could use it in places like banks and hospitality and all that. That's actually really clever. So the applications for this is actually quite far and wide-reaching, you know?
Yeah.
Okay, that's fantastic.
Yeah, and I'm sure there's some applications that we don't even think of that might be involved as well.
Yeah, absolutely.
Yeah.
So I want to ask a quick question that's been burning for quite a while with regards to this. What is the differences between sound masking and white noise?
That's a very good question, because I think that is a misconception, right?
Yes.
So sort of in layman's terms, people talk about a sound masking system as a white sound system.
Yes.
Right? And in the principle of calling it a white sound system, it's not incorrect, but it's not also 100% correct.
Okay.
Right? And the concept behind it is, or the reason behind that is, sound masking systems utilizes white sound as part of the frequencies or the background noise being introduced, right? But it is not white sound 100%. It is a tailored white sound. It has been shaped differently to what just white sound, if you look at white sound in its full frequency spectrum, has been created. So a sound masking system takes white sound as the generated noise, but it shapes that to a specific profile.
That is very clever. So it's not just that barrage of shh all the time.
Exactly.
So they actually tailor it according to the environment that it's going into.
Yeah, but not just the environment, also speech.
All
Because
right.
that's exactly what we want to achieve with a sound masking system, is we want to have speech be unintelligible to a person that's not necessarily intended to hear it, whether intentionally or unintentionally hearing that conversation, right? So white sound in this case, used in a sound masking system, is tailored to speech band and to speech frequencies, and then run at a specific level, which we'll look at in a moment, in that environment. Because it can't be at 70 dBs and you and I are talking at 60 dBs.
Yes.
It needs to be at a certain level, and we'll look at some of those details in just a moment.
Okay, so you have to be able to not really hear that noise in the office, so it's not too distracting. Is that what you just said now in the last sentence?
Correct. Right?
Okay.
So in talking about that, and I'm just trying to switch the slides here for us. So let's just quickly look at the sound spectrum of what we're talking about. So there you can see on the chart, there's a couple of different sounds there.
Okay.
So white sound, pink noise, or white noise, pink noise, right? So white sound is basically white noise.
Yes.
Pink noise and masking noise, and then there's a recommended spectrum. And we'll look at the sound spectrum a little bit later in the presentation again.
Okay.
To put this into context. But I want to use this here to just explain the concept of what I was just talking about. So white noise, right, what people refer to as white sound. So that white noise frequency, you can see that white line is shaped from being lower level on low frequencies and higher in dB level on higher frequencies, right? Because that's also part of how our ears listen to sound.
That would make sense, because when you listen to it, it's a very sharp, like shh noise.
So it gets amplified, or it gets a white sound or white noise signal is amplified on high frequencies.
Yes.
Just to shape better to our ears' way of hearing.
Oh, right.
Pink noise is essentially all frequencies at the same level. So each single frequency is 0 dBs. Whereas with white noise, as you can see, it's shaped higher on higher SPL, higher dB on higher frequencies and lower on lower
Oh,
frequencies,
that
right?
makes sense. Yes.
But now look at that masking noise.
That's got a more defined curve to it.
Correct. Within a specific bandwidth.
Yes.
Right? So you can see 250 to 4,000 hertz, which is our speech band. And it's also shaped to be higher at the low frequencies and lower at the high frequencies.
Yes, look at that. It is actually, because there when it gets to 4,000, it's making quite a significant dip there.
Yeah. And that again is to help shape how we hear sound and hear speech frequencies, right? How it falls on our ears.
Yes.
So again, that's the concept of using white noise in sound masking.
Oh, understood. Okay, so that basically gives us the exact difference between a white noise system and a sound masking system.
Yeah.
Fantastic. That's actually...
It's not necessarily a difference. It is that white sound is used inside, or white noise is used inside sound masking. It's used as part of sound masking.
Yes.
But tailored and shaped.
Correct. Where white noise is not. It's just a straight signal from, call it 38 hertz to... what, 60, 40, 400,000 there?
4,000 hertz.
4,000 hertz, yeah. Okay, all right, that makes sense.
And as I said earlier, it's shaped both in frequency and it's shaped in level, right? Because you also don't want the sound masking frequencies to be the thing causing the distraction if it's too loud.
Yes.
Right?
Okay.
As a basic example, talking about the Romans using water to mask sound, right? Using fountains and things to mask or simulate sound. If you're in an aircon environment, the aircon is sitting there in the background and just blowing away, but you turn the aircon off and all of a sudden there's the environment sounds a little bit different.
Yeah, it sounds almost a little bit louder than what it was before.
Yeah, and that's because it's at a certain level. Your brain disregards the level of it, the actual dB level, and then it falls into background noise for yourself, right? And that's exactly what sound masking should be. Sound masking should not be something that's very, very loud that is actually then becoming a distraction.
Oh, right. Okay, that makes perfect sense. All right, so let's talk about something called speech privacy. What is speech privacy and why would we need this?
Well, that's probably the most critical reason why you would want to use sound masking, right? And that's what we were talking about earlier. You want to be able to have a private conversation in certain environments.
Okay.
Right? But there's other factors as well that is related to speech privacy. It's not just having a private conversation. It's also about creating a less distracting environment.
Yes.
Right? So if we look at a couple of those examples, just trying to switch those presentations here for you as well. So speech privacy is the inability of an unintentional listener to understand another person's conversation. Okay?
Okay.
So let's say, for instance, in a call center environment, two people sitting in an open floor plan environment, they are sitting right next to each other, they're both on phone calls, you can hear the other person's conversation.
Yes.
Or if you're sitting in an open plan office and you just having a conversation, you're not necessarily at a call center, but you're having a conversation, somebody else is hearing your conversation.
Yes.
Right? That's speech privacy.
Right. Okay.
And as you can see, their speech privacy complaints are due to distractions caused by overheard conversations.
And you know how true that is? Like, have you ever tried to talk to someone and have like a conversation with them, but there's something in the background that just keeps grabbing your attention?
Yeah.
You know, and you struggle to get across what you want to say because you're being distracted by that noise in the background there. Okay, that makes perfect sense.
Looking at it more, the perceived level of distraction relates directly to the inability of the overheard conversation.
Yes, that's right. So if I can understand what that person is saying in the background, that distracts me a lot more.
Yeah. Because then your brain goes, oh, I want to hear what they're speaking about.
Yes.
And then you get distracted and you overhear a conversation. it's intentional or unintentional, but it does happen.
Yeah, look, it's there. So we need to put something to try and minimize that.
Yeah. And then lastly, the intelligibility depends on the loudness of the overheard speech, right? Compared now to the loudness of the background noise. Okay, that's the key thing here in terms of creating speech privacy, right? So there's a couple of items here in terms of what's referred to as the privacy index. So 0% would mean no privacy at all.
Yes.
Okay, that's like the lowest obviously on the spectrum, and that means you can hear a complete conversation from somebody else.
Right.
And unacceptable privacy is anything between 0 and 60%. Right? Minimal privacy is 60 to 80% of having a conversation private, so people can't ever hear it.
Right.
Normal privacy, 80 to 95%, and that should be the goal for open plan offices. You want to be within that normal privacy range.
Yes.
Right? Again, we're not trying to, or you might not want to create an environment where it's like completely private because it's an open plan environment, but you want to have the distractions of not having privacy to a minimum.
Yes.
Right?
Understood.
And then lastly, confidential privacy is 95% or greater.
Okay.
And that should be the goal for a private office, maybe a boardroom, like we mentioned earlier, government institutions where certain conversations should be 100% private, even military applications and things like that. We really want to have no overheard conversation taking place, right?
Correct.
And that could even be the case for an executive boardroom. You don't want people outside the boardroom, and there's some applications for that as well. We don't want people outside the boardroom to be able to hear the conversation inside the boardroom.
Yes, absolutely. I mean, you can be walking past that boardroom at any time of the day, and the last thing you want, if you're having that meeting in the boardroom, is for somebody to walk past and overhear you talking about company financials.
Correct.
You know?
That's not pertaining to that person.
Exactly, yes.
Right.
Exactly.
So then there's something called the speech privacy potential, and that is a measurement used primarily by the GSA to determine speech privacy. This measurement is the sum of the space's sound isolation and the background noise.
Okay.
Right? So there's some acoustical factors in here as well, and we'll look at some of those details in when we look at how do you apply these applications.
Okay, so acoustics do play sort of a role in this as
It
well.
does. It definitely does.
Okay.
It definitely does. And again, there's some figures there in terms of how good or excellent privacy rating is.
Yes.
Right. So total privacy, an SPP of 90 is shouting is barely audible.
Wow.
Right. So that would be a combination of probably all the things we'll show in terms of creating. So but we'll get to that. But good privacy is normal voice is mostly unintelligible, right? So two people at a certain distance from each other is not necessarily going to be able to hear or understand conversation if they're not actually get engaged in the conversation next to each, like they're right next to each other, they actually engage in conversation.
Okay.
That's now at a distance, and they can't necessarily hear each other's conversations, so they can focus on their own task or their own conversation that they're having, maybe on a telephone call or whatever the case might be.
Okay.
Right. Okay.
All right. So in most offices today, corporate spaces and all that, speech privacy is pretty much non-existent. So how do we get to solve the problem of unintentional listeners listening in on private conversations while at work?
So, again, just trying to switch us here. How we would achieve that is by using the... Sorry, I think I'm misunderstanding your question.
Yeah, so the question is, how would we solve the problem of unintentional listeners listening in
yes.
on private conversations at the office space?
Sorry, too much switching happening here today.
Yeah, the joys of modern technology, right?
That's it.
And especially when we're
Operating and broadcasting.
operating and broadcasting, right?
Yeah. So in that case, we would look at what Biamp Cambridge refers to as the ABCDs.
Okay.
Right. That's how you would achieve privacy.
All right.
And achieve getting an environment to the right privacy and non-distracting levels.
Okay. All right, that makes perfect sense.
Okay, so the ABCDs of architectural acoustics,
Right.
right? And this is what I said earlier. We'll get into like this. This will be these steps will determine how well the sound masking system works and what level of privacy can be achieved. Based on that speech privacy index.
Okay.
So the first of the ABCDs is A, and that's absorb.
Absorb.
Right. So acoustically, you want to have the environment at the right place, where there's absorption of a certain amount potentially taking place. And again, it depends on the environment. An open plan office with pitched roof and skylights and things, you're not going to be able to put acoustic ceiling tiles in there.
Yes.
But an open plan office with a drop down ceiling, you can put acoustic tiles, ceiling tiles, acoustic wall panels, etc., and absorb as much background noise as possible.
Okay, that makes perfect sense. So, like, in other words, if you're looking at a boardroom that's purely just glass and concrete, that's a very bad acoustic room for speech privacy.
Because sound is just going to bounce around in the room.
Yes.
And it means you have no control over the environment. And that's what the ABCs do, is you want to be able to create control over the environment that you are in, right?
Excellent. Okay.
The second step would be to block, right?
Yes.
So if maybe it's an open plan office and it's a call center, for instance, you could put partitions in between cubicles and make those cubicles absorbent, right? So now they block and they absorb. In that sense, you could make them blocking only. And that way you can start creating little confined environments of privacy, right? Or blocking out distractions. Walls is another way. An actual concrete solid wall is another way of doing it. If you think about blocking in this case, we were talking about an executive office earlier.
Yes.
So you might want to do these two things already when you construct that office.
Okay.
So you want to create absorption on the inside and maybe even on the outside of that executive office, but you also want to be able to block it. So your walls need to be able to block sound from leaking out of that acoustic space.
Yes.
Right? Of that acoustic space then being the executive boardroom. So those 2 points are already the physical environmental manipulation that you might need to do, right? So that's something you physically have to do to the environment. And that's absorb it or block it. And in some case, that means you might need to construct it differently, depending on what you want to achieve, or add these items after something has been constructed already, and which means obviously some different costs on that project.
Okay.
But the last way is C, and that's to cover the noise.
All right.
Right? And that's the sound masking system itself.
Okay, so C is this actual sound masking system that fits into the ABCDs.
Yeah.
Great.
So with cover, you basically cover the background noise. You mask the background noise, right? So that's where the sound masking system comes in. So your speakers, your emitters, your control system that you employ, and like you mentioned earlier, the Biamp Cambridge stuff is 100% perfectly matched to that. It makes it easy to install and commission those systems.
Yes.
In that environment to do the cover, right?
Okay, got it.
And that's sound masking. Sometimes, like I mentioned, it depends on what level of privacy you want to achieve and what level of distractions you want to avoid. You might need to do the A and the B, which might be a physical construction, right?
Yes.
But that's going to depend on the environment and the application. But for our all intents and purposes, we talk about the cover side.
Yes,
right?
cover side, yeah.
But these are the ABCDs. So where's the D?
Yeah, where is the D there? I actually thought you were going to finish off there at C.
The D is distance.
Right, okay.
Right. So increasing distance between two physical people is also part of something that you can do to help with the environmental, the architectural acoustics. So just maybe spacing people a little bit further apart from each other.
Yes.
Would then help those 4 or those 3 first points to already start to have a better outcome on the system. Right?
Okay, this
So-
is actually very interesting. This is very, very interesting. So I also want to ask a bit of a weird question here. So to get this right, the sound masking solution produces a sound that cancels out speech.
No. No. It doesn't cancel out speech.
Okay. So
It only masks it.
okay, so it's not like noise cancelling headphones that works with voice.
Not at all. Not at all.
So you're still going to hear the voice, right?
Yes. But like that picture that we showed right in the beginning,
Yes.
sound masking is to mask your ability to understand the conversation that's happening behind you or a distance away from you,
Yes.
right? And that masks the intelligibility of a conversation, right? So no, it doesn't cancel out that conversation, because to cancel it, that's a different application. You actually have to, like with noise cancelling headphones, you have to actually isolate the person's hearing
Yes.
in order to be able to noise cancel it. Right.
Right. Okay.
So with sound masking, it generates that sound, and I'm going to show you one or two things just now about it. It generates that sound, that shaped sound that we spoke about,
Yes.
which then masks the ability to intelligibly understand somebody else's conversation.
Understood.
Right.
So
Getting tongue-tied.
yes, I actually like what you said there. So in other words, what's happening here is if you hear somebody talking in the background and you can't understand them, or your brain can't make sense of what they're saying, you don't focus on that sound, right?
Yep. So
Ah.
so let me turn to the slide. Let me show you.
This is very interesting.
And this is what sound masking does.
Right.
So we refer to that as the signal to noise ratio, and that's a common term for electronics, for sound, for even in visual. There could be a signal to noise ratio
Yes.
in terms of film and video applications. But in this case now, we're talking about your hearing ability, your signal to noise ratio of hearing, right?
Okay.
So the signal there in that case would be the person talking,
Right.
right? So your talker on the left hand side, the tall person, that's the talker.
Okay.
And here's your signal, right? If you talk about it a little bit technical on an electrical circuit.
Yes.
So that's the sound source.
Okay.
Okay.
Yes.
He is speaking at 65 dBs. Okay,
Okay.
right?
Got that.
The person on the right hand side is 24 feet away there in that case, and I think that's about 8 meters, I think, roughly.
Mm-hmm.
So 8 meters away from the talker is the listener. Okay. There is a background noise level, the blue line, of 47 dB A-weighted.
And that can be any sort of noise in that environment.
Could be any noise.
Aircon,
Could be any noise.
traffic from outside.
And for all intents and purposes,
Yeah.
in this case, that is our sound masking level.
Okay.
So if we introduce sound masking into that environment, we want to be within that 47, 48 dB A range as sort of a maximum that you want to be able to put the sound masking system on.
Right.
Okay.
Okay.
Now you look at distance and then you look at the yellow line, and the person listening would receive the talker's speech at 47 dBs, which is exactly the same as the sound masking level.
Right.
Which now means that you won't be able to intelligibly understand the conversation. You might still hear the person speaking, but you won't be distracted by what they're saying, because you can't understand what they're saying,
Oh my gosh, this is so clever, right?
right? Because the level of speech is the same as the level of background noise.
Uh-huh.
So, again, coming back to that sort of example of an air conditioner in a room.
Yes.
If you turn the air conditioner off, all of a sudden it sounds like everything's louder.
Yes, that's right.
It's not louder. Everything is still at the same level. It's just that the background noise has been reduced.
That makes so much sense, Michael.
And that's sound masking. That's why we say it's not cancelling out the sound. It is purely creating an environment where speech at a certain distance, right? Remember the D?
Yes.
Is lower or equal to or very close to the sound masking or the background noise.
Wow.
Okay.
So that's the crux of a sound masking system.
Correct.
That is insane.
That's what it achieves, or that's how you get to it. And there's a couple of things that it does for a system, right? Or for an environment. So let's just quickly look at some key factors of creating an effective sound masking system.
Excellent.
The first one is sound spectrum, and that's what we discussed right in the beginning.
Yes, that's that curved EQ, right?
100%. So your sound spectrum needs to be correct.
Okay.
If it's the wrong spectrum, people will get distracted by the sound masking, right?
Okay, that you can set on the system itself, right? That EQ and all that stuff.
Yeah, there's a couple of things you can set on the Cambridge systems, but it's also been set for you already. So there's already a base algorithm and a base frequency that is already been tailored for speech that is available on there.
Wow.
You can then tailor that, what comes out of the system for the environment.
Sure. Thank you, Cambridge.
The second part is the sound level.
Okay.
Right? So now when you shape the sound, you want to have the shaped sound at the right level, right, to be equal or just over the background noise of the environment.
Okay.
The last thing is you want to be able to zone that system.
Ah, yes, this is a good one.
Because you might not have one big open plan environment, which is one acoustic environment. You'll see some of the examples there. You might have individual offices next to an open plan environment, or maybe even have an executive boardroom very close to that. So you want to be able to zone and manage that separately, right?
Oh, that makes perfect sense, because generally speaking, that is what an office space looks like.
Correct. And then lastly, you want to have uniformity. You can't have the sound masking louder. I'm talking in one one acoustical space. You don't want it louder in one corner than you have in another corner, because that just again creates an imbalance of background noise in that environment, which makes the sound masking system ineffective.
Oh, right. Okay. So these are good factors to take into account.
Yeah. So we've spoken about this first slide at length a little bit. So that's where that sound masked, or that masking sound shape comes into play, right? It's that sound spectrum that you introduce as a background noise. Right?
Okay.
As
excellent.
a masking sound.
See, now that makes a lot more sense now, because now we understand what's gone into that curve and why it's there, which is great.
Yeah. So here's a couple of common dB levels for specific speeches and background noise and so on.
Okay.
And starting off there, a quiet library would be around 30 dBA. Now that if you've been into a library recently, they still exist. But if you've been into a library recently, that's pretty quiet. Right?
That is very quiet. I'm actually
Very
quite
quiet.
surprised you get 30 dBs out of that, because when I went to a library when I was a kid, it was dead quiet.
Yeah.
Like
That
nobody
would
said
have been-
anything.
Would have been around that 30 dBA level.
Wow, I didn't even know there would be 30 dBs. Interesting.
Office conversation like you and I are having now, that's roughly around 60 dBA. Right? That's
Okay.
roughly where normal conversation would be.
Okay.
A vacuum cleaner in an office, 70 dBs.
Gee, I think it sounds a lot louder than that in our
Yeah.
office.
But let's use that as an example.
Yes.
Once a vacuum cleaner is going, you can't understand conversations because
absolutely not.
it's just way too loud.
Yeah,
right?
it is.
But it's also distracting,
Very distracting.
right? Because it's too loud again.
Yes.
Garbage disposal, something like a paper shredder,
Yeah.
right? Could be at 80 dBs. That could be quite loud. Somebody drilling in the office. Somebody's making alterations, or next door neighbors making alterations. Power drill, 98 dBs is almost 100
that
dBs.
is the worst distracting sound ever, especially when the neighbor does it and you live in like one of those complexes where you're right next door to each other. That is the
It
worst
gets loud.
sound.
It gets loud. Now 100 dBs, 98 dBs, 100 dBs is a rock concert.
Really?
Yeah. It starts equating to
That's a rock concert, the
outdoor rock
same
concert,
volume.
Yeah.
Wow, Michael.
It's loud, eh? It's loud.
That is pretty loud.
So that's why we say the sound masking system needs to be between that sort of quiet library and your general conversation. Right?
Okay.
And the ideal sort of level is about 48 dBA.
48 dBA.
Right.
Okay.
Making it too much louder than that becomes distracting again. So then it's negating the effect of the system. The system is there to minimize distractions,
Yes.
not create another distraction.
Absolutely correct.
And then to mask conversation so that privacy can be maintained and people can actually concentrate and focus on what they're doing. So that's the level. The zoning scenario,
Yes.
In this environment, you can see that, as we mentioned, there's an open plan office, there's a reception area there, and there's a couple of private offices and a conference room.
Yes.
So you want to be able to zone this and control them separately, because you don't necessarily have the same amount of sound masking required in the individual offices than you might have in the open plan.
Right. That makes perfect
So
sense.
you want to be able to control that separately, and even reception might be at a different level for that environment.
Okay. That
So
makes
you want to be able
perfect sense.
to control those separately, and again, the Cambridge systems allows for that multiple zoning. We're not going to go into too much of the details of the systems itself. I think we've got a couple of other webinars that we'll share with the guys that talks about the specific products and so on. So today we're just covering what it does and sort of the more technicality behind sound masking systems.
Okay, we will drop that link in the comments, guys, because we have done a previous show detailing this a bit more. So we will drop that in the comments there for you guys.
Yeah. And then lastly, as we mentioned, uniformity, right? You can see that graphic. You want to cover the area equally.
Yes.
Right? If you take one of the lines, one of the vertical rows out, and the one side of the property is not properly masked, then conversation in that area can be overheard.
Yes,
right?
correct.
So you want to have uniformity in each of the specific zones. Right, and there's lots of guides, again, like we said, on the other presentations that we do, that shows how to set that up, how to calculate it. And there's some general guidelines that Biamp and Cambridge provide for how to calculate it.
Yes, and best install practices as well.
Yeah,
absolutely.
100%.
Yeah, absolutely.
So again, just in summary, so sound spectrum, you want to shape your sound level, want to have it correct, you want to have proper zoning, and then create uniformity in the environment in terms of the actual sound masking system itself.
Fantastic. Mike, I want to ask you one last question. Okay, so in order for all of this to work, does somebody need to go into the office, like an installer or reseller, with a dB meter and measure what the office noise is first before we calculate what the sound spectrum should be in the sound level, etc., etc.?
In general terms, yes, we would do that in the past.
Okay.
But like I mentioned, the Cambridge systems have been pre-programmed for the right spectrum.
Okay.
Right? What you would want to do is just make sure that your environment or your sound spectrum is coming across correctly.
Okay.
Right? So Cambridge does offer EQ sections for just adjusting the output EQs of each of the zones so that you can get that to match in the environment correctly. So the short answer is yes, still do that. Take a dB meter in, take a spectrum analyzer in, and measure it, get the background noise level, make sure you understand what the noise level is, and then take your tailored shape and maybe adjust it slightly on EQ to match that physical environment.
Yes.
Right? Because
yes.
the environment also plays a part.
Yes, it does.
Of the sound masking shape, right? The mask shape, the sound spectrum shape, as we said.
Okay.
So yes, that you can still do that, but the system also allows you to auto calibrate that in some ways. It depends on how you put the system together. There's some emitters that can actually measure some of the sound, and it can adjust, and you can adjust level up and down automatically and maintain certain things. But like I said, that's part of our technical presentations on the product.
Yes.
So there are ways of managing that after installation and during installation.
Okay, that's very clever. So actually, the guys actually make it really easy to install this and calibrate it quickly.
Correct.
So
Correct.
less time on site, save the customer money,
Yep.
and you walk away with a win.
100%.
Excellent. Excellent, Mike. All right, so I think that pretty much covers it for the show today, unless you want to discuss a few benefits there of what sound masking is.
Yeah, we can just quickly touch on that.
Okay.
And I'll swap this part there. So some of the benefits that we were touching on and talking about. Number one is it will protect your speech privacy, right?
Yes.
It'll make conversations private, which in some cases would just reduce noise and distractions. Okay. And in other cases, you want to have it completely private, right? Some cases not completely private, as we mentioned, in terms of the privacy index, but it will reduce your noise distractions. You and I were actually talking about it earlier. There's some statistics that show that distractions for an employee in a workspace. They get distracted about every 11 minutes.
Wow, that much, hey?
And once they're distracted, it takes them up to 23 minutes to get back to concentrating on the task that they were doing.
That's quite a bit
Once
of time wasted.
once they've been distracted. So
Yeah.
you can imagine just the sort of cost of investment of putting in a sound masking system and then raising productivity of your workforce.
Mm-hmm.
Right? That already pays for the cost of investments of injecting the product into that environment.
Absolutely.
Installing the product in that environment. So there's lots of benefits, and there's even probably a few things that we didn't discuss in too much detail. But then it also improves the workspace acoustics, right?
Okay.
So as part of the ABCDs, you might look at the physical acoustics and adjust some things. But with putting the sound masking into the space, it also just reduces, like we said, reduces the distractions, reduces the overall working environment. Actually makes it more comfortable. People tend to be more comfortable. You guys have one in the sales office, and you guys experience it every day. But do you notice that it's actually on?
No,
You
we
know?
don't.
And that's the other thing. You get so used to the system being on that you actually, when you walk in, it's just, you know that it's on, but you don't actually know that it's on.
Yes, and that is a real bonus because, I mean, as you've heard a lot of the times, that sales office where we work from is actually quite noisy.
Yep.
You know, I mean, there's people talking to clients and you get excited, you want to tell them about a new product, and then everybody else can hear it and it kind of distracts them as well.
Yeah.
But since we've put in that sound masking, that distraction level has significantly decreased.
Yeah.
You know, making us more effective at our
More,
jobs.
more productive.
Oh, yes, more productive. Yes.
More productive.
Bosses love that word, right?
So, yes. Yeah.
Great, Michael. That was a fantastic show. And like I mentioned earlier, this is one of my favorite topics to discuss. And I'm glad I did it with you today, Mike. It was fantastic. Thank you so much for joining us on the show today. And guys, thanks for joining us as well. We will drop all those web addresses in the comment section when we're done with the video. And guys, please don't forget to like the video, subscribe to our YouTube channel so you always get content. And for any additional content, guys, we do have a training section on our Alphatron website, which is www.alpha-tec.co.za. Click on the training tab, and you guys can see a whole host of training videos there, which we've put there for you as well.
Yeah.
But guys, please don't forget to like and subscribe. Michael, thank you very much for joining us today. Absolute pleasure to have you on the show.
Good. We'll do it again.
Absolutely, guys. Cheers.